We seem to have rediscovered one of the secrets of Nikola Tesla, how he could use a big Tesla coil to send energy not only to light bulbs nearby, but also through an antenna to other light bulbs far away. He did this by means of resonance with the earth. What do we mean by resonance? It's just like for this singing bowl. When you hit it, it vibrates and keeps vibrating. An electrical circuit can do the same thing. If you would like to learn more about this possible new source of free energy, please watch the video and share it with your friends. Nikola Tesla in 1900 built a huge Tesla coil on Long Island, which he called Wardenclyffe Tower. And here's my little Tesla coil here, and you can see a wire from it will light up this bulb in direct proximity. And we're only running it 50 volts, 20 watts. Now, how was he going to send all that power to New York City? Well, he might have been doing it through the air. So in order to test that idea, I've put a little antenna here made of aluminium foil from the kitchen. There's a wire leading from the antenna to a detector over there, and you can see a light's turning on. So today, to start, we're going to learn the physics of how Tesla could have sent it to New York City through the air. First, if we run a white wire from that antenna, which is collecting energy from the Tesla coil at 20 watts, through space, and run that white wire over here and attach it to a G4 LED, it lights up a little bit when it's attached to ground. If I touch the ground connection to make a stronger ground, the light gets even stronger. Next, if we place the Schottky diode in front of that LED, which rectifies high frequency AC to DC, it's about 500 kilohertz, we see about 300 millivolts when the light is weak. Or if I touch the aluminium block to provide more ground current, the light gets stronger, and we see a more substantial 1.6 volts DC. Finally, if I add a special wire coil to the white wire from the antenna, which is receiving energy from the Tesla coil through space, this coil is resonant with ground, has an inductance of about 2.0 millihenries. Then we have a Schottky diode, then we have a light, and when I'm not touching the aluminium plate, just leaving it there, we see a more substantial 0.9 millivolt just from the coil alone. And then when I touch the aluminium block, the light gets much brighter, and we see about 13 volts DC, which is quite substantial. We look at high frequency AC current coming through this system. When I'm not touching the block and the ground is weak, we see very, very little AC voltage. But then when I touch the block, the light gets much stronger. We see the AC voltages like going like in a capacitor, charging and discharging at about 200 volts. So we've definitely formed, using this wire coil and the ground, some kind of resonant LC circuit, which is storing energy from the ground and making the light come on strongly. The high frequency AC current going in series between the Schottky diode and the light is about 600 microamps, not touching anything. When I put my hand even near the aluminium block, it goes up to 2 milliamps, 3 milliamps. If I touch it, it just overloads. At the same time, DC voltage across the Schottky diode and the LED starts at about 3 volts, not touching it with the ground. And then if I touch the aluminium to make a more ground, you can see the light gets much brighter and the voltage goes up to about 17 volts DC. Now that you have seen all of the data, I'm going to explain how it works. First, wireless energy comes out of that Tesla coil over there and strikes this antenna, at a frequency of 525 kilohertz. That's 525,000 times per second. Then it goes through this white wire into this wire coil here of 1.25 millimeter wire, 0.8 ohms resistance, and an inductance of 2.0 millihenries. Now, inductance just simply means how strong a magnetic field it makes when electric current goes through it. Next, the high frequency electricity, which has been added to this wire coil, goes through a Schottky diode, which switches AC to DC at high frequencies, and a G4 LED test light, and those three objects combined have a total capacitance of about 35 to 45 picofarad. And that's its ability of this circuit in its entirety to store electricity, somewhat like for a battery. Now, we've explained thus far how AC energy comes out of the Tesla coil through the air at a frequency of 525 kilohertz into an antenna, goes through a wire into this wire coil, which has an inductance of L equals 2.0 millihenry, and that's how magnetic it gets when electricity goes through it. Then it goes into a Schottky diode and a G4 LED. That makes DC power, and this gives you a test light. And that whole dotted area has what's called a capacitance, ability to store electricity of 45 picofarad. So if you look at those three numbers, 525 kilohertz for frequency, inductance 2.0 millihenry, capacitance 45 picofarad, this dotted area here makes what's called a resonance circuit, where electricity goes back and forth very quickly at 525,000 times per second. And the way that works, if you don't understand it, it's just like a singing bowl. When you hit that region, it rings in electricity. In order to make our test light stronger, we can attach this LC circuit to an aluminium block. There are enough free electrons in that block to leave the block, go into this LC circuit, where instead of a little bit of vibrations, we can have a lot of current vibrating back and forth. Next, if we put my hand on the aluminium block so my whole body's providing electrons, then the light becomes very strong. So what we're seeing here is we can add electrons from an outside source, a block on my body, the whole Earth, to an LC circuit at very high frequencies using single wire electricity, and increase the strength of the LC resonance that way to give much more power. This doesn't work at low frequencies because they're only plus and minus wires, but for single wire electricity like we're using here from a Tesla coil, just one wire, it works, and it seems to be a new phenomenon in electricity not studied before. Whether this represents free energy like waterfalls and wind farms is hard to tell, but it's certainly worth exploring further. This wire coil with 2.0 millihenries of inductance is essential to get a lot of AC current at high frequency coming through that LED light when I touch the aluminium and ground it. And what's happening is electrons are coming up through the ground, forming a resonance circuit with that particular coil, and giving high frequency AC current at about 500 kilohertz. Just as further proof of that hypothesis, if we disconnect the resonant coil like this, or use some other non-resonant coil, then grounding the aluminium has almost no effect. No electrons come through the system. Then when we reattach that wire coil to make a resonant LC circuit with ground, we touch the aluminium, we get extremely bright light. Go Tesla!